Uncle and Yaidus. Today I am back with the new topic, what are the forces required for measuring instruments. Let us watch this entire video without skipping. There are three forces are required: deflecting force, controlling force and damping force. Let us discuss what is deflecting force. When there is no input signal to the instruments, the pointer will be at its zero position. To deflect or move the pointer from its zero position, a force is necessary which is called as deflecting force. ఎప్పుడైతే ఇన్స్ట్రుమెంట్కి ఇన్పుట్ సిగ్నల్ లేకుంటుందో అప్పుడు పాయింటర్ అనేది జీరో పొజిషన్లో ఉంటుంది. అంటే పాయింటర్ని మూవ్ చేయడానికి జీరో పొజిషన్ నుంచి ఒక సర్టెన్ పొజిషన్కి మూవ్ కావాలి అంటే ఒక ఫోర్స్ అనేది అవసరం అన్నమాట. ఆ ఫోర్సే డిఫ్లెక్టింగ్ ఫోర్స్. Here this is the scale and this is the pointer. Then from zero position to the pointer is moved, a force is required, that is deflecting force. A system which produces the deflecting force is known as the deflecting system. Generally, a deflecting system converts an electrical signal to a mechanical force, which means electrical signal to mechanical force. Then deflecting force is explained in three cases. One is magnitude effect and forces between permanent coil and current carrying coil, and force between two current carrying coils. Discuss what is magnitude effect. Then we are considering only current carrying coil. Whenever a current flows through this coil, an imaginary bar magnet will be produced. Then, depending upon the current direction, poles are generated. Then there will be a force of attraction between coil and a soft iron piece. Whenever a soft iron piece is brought near this coil, the coil and soft iron piece get magnetized. This type of principle is used in moving iron type, attraction type instrument, which means only single iron piece is brought near the current carrying coil. Then there will be a force of attraction. If two soft iron pieces are brought near to the current carrying coil, there will be a force of repulsion between two soft iron pieces. This principle is used in moving iron repulsion type instrument. Going to next topic, force between permanent magnet and current carrying coil. Let us consider permanent magnet and current carrying coil. Then whenever a current flowing through this coil, the field is produced in a permanent magnet, and also a force is produced between permanent magnet and current carrying coil. This principle is used in moving coil type instrument. Let us discuss third case, force between two current carrying coils. Let us consider two current carrying coils. One is fixed one and another one is movable coil. Whenever two current carrying coils are placed closer to each other, then there will be a force of repulsion between two coils. If one coil is movable, another one is fixed, the movable coil will move away from the fixed one. This principle is used in electrodynamometer type instrument. What is controlling force? To make the measurement indicated the pointer definite, a force is necessary which will be acting in the opposite direction to the deflecting force. This force is known as controlling force. When the external signal to be measured by the instrument is removed, the pointer should be return back to the original position. When the deflecting torque and controlling torque is equal, the external signal to be measured by the instrument is removed, then the pointer will be returned back to the zero position. The pointer will be indicating a steady value due to the controlling force. Controlling force is produced by spring control. two springs are placed either end of the spindle. This spindle is fixed to jeweled bearings. The frictional force between pivot and jeweled bearings will be minimum. The springs are made up of phosphorus bronze. Current is supplied to the instrument. Then the pointer will be moved due to the rotation of the spindle. While spindle is rotating, the spring attached to the spindle will oppose the movement of the pointer. The torque produced by the spring is directly proportional to the pointer deflection. Depending upon the current, the deflecting force is produced through the pointer. Then deflecting force is directly proportional to I, current. The pointer will come to a steady state position when controlling torque is directly proportional to deflecting torque. Since theta and a current are directly proportional to the scale of such instrument. Coming to damping force. What is damping force? The deflection and controlling torques are produced by the systems are electromechanical. Due to inertia produced by this instrument, the pointer oscillates about its final steady state position before coming to its rest. The time required to take the measurement is more. To damp out the oscillation is quickly. A damping force is necessary. To eliminate oscillations, damping force is necessary. This force is produced by different systems: air friction damping, and second one is fluid friction damping, and third one is eddy current damping. Here only two types of dampings are discussing: air friction damping and eddy current damping. Coming to air friction damping. Depending upon the pointer direction, air friction damping is explained in two cases. One is pointer moves anti-clockwise direction and pointer moves clockwise direction. The piston is connected to a spindle through a connecting rod. This is the connecting rod, and also the pointer is fixed to a spindle, moves over a calibrated scale. Whenever a pointer oscillates in clockwise direction, then the piston goes inside and also the cylinder gets compressed. The air pushes piston upwards. The pointer tends to move in anti-clockwise direction, which means the pointer coming to its rest. Second case, if the pointer oscillates in anti-clockwise direction, the piston moves away from the cylinder. The pressure of the air gets reduced. The external pressure is more than the internal pressure. Therefore, the piston moves downwards. The pointer tends to move in clockwise direction. Now, what is eddy current damping? Here, two types of instruments are used in eddy current damping. One is disc type instrument and another one is rectangular type instrument. Construction is different in both type of instruments, but working is same as the disc type instrument and rectangular type instruments. Here, aluminum disc is placed near to the spindle. The disc made to move in the magnetic field produced by a permanent magnet. When the disc gets oscillates, it cuts the magnetic flux produced by the damping magnet, and electromagnetic force is produced in the circular disc by Faraday's law. Then eddy currents are produced in the disc. Since it has several closed paths, by producing several closed paths, eddy currents are produced. By Lenz's law, the current carrying disc produced a force of oscillating force. Thank you for watching this video. Once go through syllabus copy of measuring instruments and also watch the previous topic. The links are added to the description. If you like this video, please like, share and subscribe to my YouTube channel, and don't forget to click on bell icon. Keep watching. Thank you. Bye bye.